So ladies and gentlemen, I want to take this opportunity to welcome all of you to the program for today. Okay, is the essence of what we are going to do is panel data econometrics. Panel data econometrics. Basically, there are lots of things, but I just want to keep it quite simple in general. Okay. So I want to start by telling you the different types of data. Most of you have given me some examples the last time we met. Cross-sectional data is at a point in time. Time series data is over time. Panel data is across time and across individuals. Cross-sectional is across individuals, but at a time. Time series is across time per individual. That means it is at an individual level. Panel data is across time and is across individuals. So those are the main difference that you want to take note. Venice, ask your question.
Doc, please, can you throw a little more light on the panel data for me? Maybe an example will do.
All right, so let me give you an example. Okay. So let's say that you have this data I'm about to show you. Okay. You have country. Okay. And these countries are many. So you have Ghana, you have Nigeria, you have UK, you have US, and on and on and on. And each country has a GDP. So you record the GDP of Ghana, GDP of Nigeria, GDP of UK, GDP of US. Each country also has inflation. So you have inflation for Ghana, inflation for Nigeria, inflation for that. But in all of this that I'm saying, I've not told you which year am I even looking at. So now I have to show you the year. The year in question is the year 2000. So all of the variables I'm giving you are for the year 2000. The year 2000. Now I go and do the same thing for the year 2001. For the year 2001. The same firms, the same countries, okay, the year 2001, okay, the year 2001. And then I do it for the year 2002 and all of that. As long as you have the same observation appearing every other year, you now have the panel data. And the variables are multiple. So you have GDP inflation, you can have exchange rate, you can have unemployment level. And each of these are got, so you have multiple variables, multiple firms, multiple years. Dennis, do you get it?
Yes, please. Thank you very much.
But there's a difference. There are two kinds of panel. One is called balanced. The other is unbalanced. Who can tell me the difference between the two? Balanced and unbalanced. What is the difference between the two? So that people like Dennis will be able to get it. What is the difference between a balanced panel data and an unbalanced panel data? Yeah, here. Yeah, answer. Oh, yeah. Yes, tell me the difference, yeah?
Yes, sir. Oh, please, if I tell you, I'll be guessing.
Okay. We don't want guess. We don't want guesses. So let's go to Osman. Tell us.
Look, please, it is balanced when the time period is the same.
And then?
And I think the opposite is there.
What is the opposite? Teach when you are answering something. Hold on. When you are answering something, teach it instead of saying it.
Okay, Doc. So it is said it's balanced when the time period is the same.
What do you mean by that?
When the panel data.
You see the example I'm just giving right now. Use that example to explain what you mean.
Hello, Doc.
Yeah, use the example I've given on the screen to explain what you mean by balance and unbalanced.
Doc, I'm not getting an example here. Okay, Doc, let me try and get my screen. I'm using my phone. Okay. So the balanced one is the first data, that is the year 2000, 2000, 2000. I think that's the balanced data. And the unbalanced is the second one, that's the 2001, 2002. If I think I had the dates, the years correct over there. No.
All right, so that's the reason why I get to know that you don't know or you know. When you are not able to explain like you've tried and you couldn't do, that is when I know that you are teaching or you are telling me. Okay? But you've tried, but what you said is wrong. Okay? But again, I like that because that helps me to know whether what you said earlier was the way it's supposed to be. What is the main difference between balance and unbalanced? Grace?
Doc, please, when the observations for all the variables is the same from 2000 to 2001.
So give me an example of what you mean. Give me an example of what you mean by is the same.
When you have all the observations from 2000 to 2001, 2011.
The observations that I have here are 11. We have 11 observations here. Yes. So what do you mean?
So when you have observations for all the 11, for all the years equally, that's for the balance.
Use 11 as an example. You are not still using 11 as an example for a layman to understand the difference between balance and unbalanced.
Doc, please, when you have observations for all 11 years, for the 11 years, for all the observations. So for every single observation, you have 11 years of data. Yeah, so that would be the balanced panel. And then the unbalanced one is when some of the observations don't have for all the 11 years. So some have up to 11 years, some do not have up to 11 years.
Okay, that's it. You are making me force you to teach. That's it. So the difference between balanced and unbalanced is that if you have these countries that are 11 in the year 2000, these same countries that are 11 must appear in the year 2001. If UK didn't have a particular data, say inflation, it didn't have, but it has GDP, it has something else, okay? You cannot, and this is very important, you cannot say that it is unbalanced. It is still balanced. The only thing is that it doesn't have that particular variable. So one way to deal with that variable is to do interpolation. Interpolation is a whole new thing that you can learn. Okay? And I let my students do that a lot. My PhD and my master's students, they do that. So you've got to do interpolation to get the value. Sometimes we call it a missing value. But that is different from when the whole chunk of information on UK is not there at all because UK was not there. So when that, let's say it is a bank and that bank was not existing at all, you can't force to give it variables. That is when it becomes what? Unbalanced. And so you got to make it balanced. But the first one I explained, you can still make it unbalanced by removing that data simply because they didn't have the data on inflation, which is not healthy because that would mean that you can be removing a lot of information away. So know the difference between balance and unbalanced panel. Okay. That is it. Balance, they are all the same. So 11 every year, 11 every year, 11, every firm is appearing. Okay, that is balance. All right, Richmond.
Yes, Doc, I wanted to ask that, assuming you are studying a group of PhD students, so let's say you start from the year 2020, and you are studying the performance of first-year PhD students. So your concentration is on first year. So it means that every year new students come through. So you study for 2000, the year 2020, the year 2021 batch, and so on and so forth. Can we also define that as a panel data?
Yes, but what kind of panel is that? Balanced or unbalanced? You?
I think, if I guess it's right, that would be unbalanced.
Good. Guys, let me ask you a question, all of you. Let me ask you a question. So you have 11 countries here, okay? And then we went to the subsequent year, 11 countries, but Nigeria is not part of the second one, but Gabon has been added to that second one. That is why it is 11. Is it balanced or unbalanced?
Unbalanced.
Unbalanced. Unbalanced, okay, that's it. So it is still unbalanced, even though it is 11. Okay, it is appearance each year that matters, not just the number of observations. Okay. So please take note. Yes, Boyson. All right, so let's go on now. Yes.
In a situation where for each year, a new set of 11 countries are chosen. So let's say over a 10-year span, can we say that is a panel data also?
Can somebody raise a hand and answer him for me? Can somebody raise a hand, unless you didn't get a question? All right, so it's still unbalanced. You can't still say that it's balanced. It's unbalanced sample, okay? See, the thing must appear every year. That's it. For it to be balanced, if you have 30 companies, the same 30 companies must appear every year. So it must be 30. So if there are 10 years, you should have 30 times 10, 300. And those 300, every one of them must appear every year for it to be balanced. Even if you still have 30, but some joined and some left, it's not balanced anymore. Yeah, all right, let's move on. Okay. Let's look at, and again, you'll be critiquing some of this. So let's quickly look at what do we use to describe a balanced panel and an unbalanced panel and a time series and a cross-sectional. Here is it. In a balanced panel, you need to have the time T, which starts from 1 all the way to capital T. That has to be there for it to be a time dependent. You must also have an individual. An individual can be cities, it can be countries, it can be companies, it can be human beings, it can be cars, it can be farms, it can be CEOs. That is the individual. The individual is I from 1 to N. N is the total number of individuals. Okay? And the I is an individual, a particular individual in question. Okay. So take note of that. So a balanced panel has both a cross-sectional part and a time series part. All right. Now, why do we need a balanced panel? You need a balanced panel for 4 main reasons, actually. Balanced panel will increase the number. So even, and again, I'm not talking about, sorry. Why do we need a panel data, not a balanced panel? Why do we need a panel data? A panel data will increase the number, whether it's balanced or unbalanced. So you have a lot, and you know more is better. According to the Z formula, the number of observations must be large. 30 or more is large, but more is better. So when you have a balanced panel, so your number of firms you are dealing with in a particular year are small. How many firms? 10 firms. 10 firms. So why don't you add another year and another year and another year, but the same firms, and that will get you more sample. And that is good. Why is that good? Because it can reduce a problem in regression known as multicollinearity. It can also reduce a problem known as heterogeneity. 2, it is very informative. A balanced panel can detect the patterns and then trends in the data. It can detect those things. 3, you can control for unobserved factors, omitted variables, invisible items. For example, the ability of a human being cannot be seen, but that ability can indicate why his salary is higher. So how many years of experience do you have? 10 years. Okay. How many years of experience do you have? 7 years. Okay. But you might think that the 10 years person must be doing better than the 7 years. But then the 7 years, anytime you go and check, the 7 years experienced person is doing better. Is doing better. Okay. So they pay that person more than the 10 years experienced person. Why? There must be some unmeasured, invisible, hidden, latent factors that are not there. You can detect those latent factors. We call them heterogeneities, unobserved. And you can find those things in a panel data set. So those are, and of course, with panel data set, you can find a lot of things like non-stationarity. You can detect measurement errors and a lot of dynamic analysis. So that is why it is important to go for panel. But before we look at the panel data, let's look at the cross-sectional data. This is a model for cross-sectional data. Y is a dependent variable. Alpha is a constant or the intercept. And then all the independent variables in a matrix form here. UI is the error term. We call it a stochastic noise more when you are dealing with time series. Now, in a time series model, the focus is on the time. Watch the cross-sectional model. There's I, there's I, there's I. Watch the time series model. There's T, there's T, there's T. Watch the panel. And again, you're going to see the panel very soon. And you see that the panel has both IT, IT, IT. Panel changes across individuals and across time, across individuals and across time. Now let's look at the assumptions of regression. And again, I'm talking about panel. You may have heard about some of the assumptions of regression in cross-section, but there are a couple more that enter into panel that are not really in cross-section. One, the one that we know in cross-section, like weak exogeneity, is common, where you say the expected value of the error term must be 0. But the expected value of the error term given the independent variable is what must be 0. Okay. Without this assumption, there will be a problem called endogeneity. Without giving the independent variable, you have a problem of endogeneity. And then the beta parameters, the coefficient will be inconsistent. They will not be blue. When we say they will not be blue, what I mean is that they will not be best linear unbiased estimator. Yes, somebody's hand went up. Okay. All right, so let's move on. The next one is homoscedasticity. I've told you that before. The variance must be constant. The variance of the error must be constant. We know that already. Opposite is hetero. The next one, which is very pronounced, is autocorrelation. So there must be no serial correlation. Please note the serial correlation here is about the errors. So the errors of last year must not be correlated with the errors of this year. They must be orthogonal. They must be orthogonal. Now that is similar to multicollinearity. Multicollinearity is about the independent variables, the errors, and then autocorrelation is about the errors. So multico, when you hear of the multico, it's about the independent variables. When you hear of autoco, okay, that one is about the errors. So take note of the difference. They all talk about the same thing, but one is about the errors, one is about the independent variables. With a panel data, you can solve all of those two problems. Next, there must be no endogeneity. I have mentioned endogeneity, but I'm mentioning endogeneity here in a different context. The relationship between the independent variable and the error term, they must not be related. See, multicollinearity says that, listen carefully. Multicollinearity says that there must be no relationship, or there must be less relationship between the independent variables, the predictors. They must not be related. Multico. Otoko says that the errors must not be related. Otoko. Endoji says that the errors and the predictors must not be related. See the thing. And when they are related, then the dependent variable, which is a y, will also be related with the error. If the independent variable is related with the error, because the independent variable is affecting the dependent variable will also be related with the error. Endogeneity. So we don't want these things to happen. And that is clear when it comes to this. One way you can handle some of this is by using different models. For example, you can use generalized least squares for models with heteroscedasticity and autocorrelation. You can use instrumental variable regressions like two-stage least squares, systems GMM, difference GMM, different kinds of GMM, okay, to handle the problem of endogeneity. We'll look at all these. We're going to look at all this, whether you like it or not. You're going to look at all this before you finish this thing. Okay. Some of you have to start calling your parents, okay, and ask them why they encourage you to do your PhD. All right, now let's go and look at a typical general panel data model. This is general. What makes this a panel? Who can tell me? There are three things that make this a panel. What makes this a panel data? You can tell me. You can tell me, I'll call you. Isaac Abo. Isaac Abo.
Yes, Doc. Doc, please, it is the presence of I and T.
The presence of I and T, that makes it a panel. That's one. Very good. That's one. What else? What else makes it a panel? Can tell me. What else? Boyson.
You see that the error term has a time dimension, and then it has entities, a dimension of entities, as well as the stochastic one, which is both time and then across entities.
Yeah, you've explained too much. And there's something very simple before what you even said that makes this a panel. Can tell me. There's something else that makes it a panel before what you just said. What is it? Yes, Jewel.
Okay, Doc, let me see if I can get this one. Are you highlighting it? Is it a matter of its interdependence that we see happening? Is that it?
There is something. Boyson, is your hand up again? Is your hand up?
It was the other one, but
continue. Okay, so you lower it so that I don't call it. All right, so ladies and gentlemen, you can see that the error term is made up of three things. That is why. The error term is composed of three things. The first one, we're going to look at each one. In fact, it's this error term that makes the panel. Okay, so the first one is this. The dependent variable is YT. You know that already. The independent variables are XIT. These ones, yeah, XIT, the independent variables. I've taken the transpose of the matrix, so don't worry. Okay. So this is XIT, that's the independent variable. The dependent variable is this. In a panel model, you don't need this. You don't need the alpha. They will fall into the error. So if you look at the proper one I'm giving you here, a proper panel data model here, you can see that I have removed the intercept. So be used to not including the intercept, because that should be absorbed into the errors in a proper model. Now, so we have the independent variables, we have the dependent variables. What about the elements? Okay. What about the elements? We have the first term. This is known as UI. The UI is the individual specific factors. Take note, the UI are the individual specific effects. What are those? They are those unmeasured factors that are individualistic. Take, for example, you're looking at banks. There are some banks that have some specific unique characteristics that are individualistic. For example, one bank is a foreign bank, another bank is a domestic bank. That makes them unique in the way that is an individual specific factor. Sometimes it is an industry. So we can say industry specific factor. Sometimes it's economy. So we call it macro specific factor. But we don't want to go too much macro. We want to go market and individual. So the UI is dealing with those peculiar factors that make that firm, that person, that individual unique, which is not seen. It is unobservable. That is why it's in the error term, the disturbance term. It is only changing across individuals. It doesn't change over time. For example, over time, then you become foreign, you become domestic, you become foreign every year. No, it doesn't change over time. But if you look at across the individual firms, this one is foreign, this one is domestic, this one is state, this one is foreign, this one is domestic, this one is state. It is changing. It is changing across individuals. That's why it has I. So let me ask you guys. Okay, before I do, let me talk about the next one. The next one is the lambda T. That is a time dummy. The time dummy changes across time, but not across individuals. Do you know there are some things in the world that change across time? Who can give me some? They don't change across individuals per se. They change across time. Across time. Such as what? Who can tell me some of them? Dennis.
Well, can we give inflation as an example?
It is. Inflation is an example in a particular country. As long as you don't make it countrywide or cross-country study. Because the moment you make it cross-country, somebody will say the inflation in Togo is different from the inflation in UK and that of Ghana. That is cross-country. But within a country, the inflation is changing across time, not across different Ghana. Isaac, give me an example.
Doc, please, minimum wage.
Minimum wage is changing across time. And again, within the country, as long as you are not looking across country. GDP. So now let's put all together and call it all the macroeconomic factors. All the macroeconomic indicators, okay, they are changing across time. Okay? They are changing across time. Those are the things that you see here. So watch it. We call it symmetric time trend. If you are doing any analysis, you've got to be able to see. Now, how do you bring that? How do you bring it into your model? You create a dummy. So you create time dummy for them. How do you do that? You will do it. How do you create a time dummy? So you say that the year 2000, that firm was there. So it has a value of 1. The year 2001, that firm was not there. So it has a value of 0. 2002, it wasn't there. Has a value of 0. 2003, it wasn't there. Has a value of 0. 2009, it was there. Has a value of 1. So you use dummy variables to represent the time dummies for each year. For each year. So this is how you, so when you see this thing that the lambda T, okay, you see this lambda T, and that one is the composition of all of these elements up to the last time. And what's the last time? The last time is T minus 1. Okay, so T minus 1 last time, they are all combined into the time dummies. We use this a lot when you want to regulate for, you want to you want to consider the possibility of regulations or macroeconomic factors affecting your results. Technological dynamics, all the technological docile, all of these factors that are time dependent. That's what we're talking about. Okay, so take note of that time element. Now, the next one is the one that combines all of them. So you can see here, I have UIT. The UIT has all of these things, but then the last one is epsilon IT. The epsilon IT is a time dummy plus a processional. Okay. The epsilon IT. The epsilon IT, watch it carefully. You see that it is normally distributed independently and identically distributed. IID means that it's been independently and identically distributed with a zero mean and a constant variance. So that one is a proper error term. That's a proper error. The one we call the error. That same cross-sectional error that you had, that's the one. Every other thing is inside that one. And please know that it assumes strict exogeneity. The expected value of the error term must be 0. It is a strictly, it must be 0. So you're expecting that when you have estimated the results, the expected value of the error must be 0. It is important you know this because there's something that you need to know about this that a lot of papers don't do. Let's go to the predictors, the error, the independent variables. So the independent variables, there are 2 types. There are 2 types. Actually, there are 3. You have those independent variables that are time varying and those that are time invariant. The time varying ones are those that change across time. They change across time. Okay. So, for example, your income, your salary changes across time, but it also changes across individuals. So whenever you see the XI, the independent variable has an I and a T, it means that it's changing across time and across individuals. Your salary changes across time and individuals. But inflation in Ghana changes across time. So in this case, inflation is time varying, but it is only Ghana. So it becomes individual constant or individual invariant. I want to repeat that. When it is individual invariant, when it is invariant, it means it doesn't change with that thing. So if you look at inflation, inflation doesn't change across each human being. Inflation doesn't change between Bondon and Boyson. Inflation doesn't change between Isaac and Jewel. Okay, inflation is time varying, it's not individual varying, and so we call it individual invariant. Welcome. Okay, so that is what you want to know about that. Time invariant, note, time invariant means that it doesn't change with time. So it is time constant. So the word invariant is also constant. For example, gender, it doesn't change with time. And again, we are being realistic. We are being realistic here. Race does not change with time. And when we say time, we are talking about just about a year. We want to use a year to reflect the time. Okay? Even though some might change over a long period of time, but every year doesn't change. Every year doesn't change. Gender doesn't change every year. Even if you want to change your gender, you don't change it every year. And race doesn't change every year. And education doesn't change every year. And again, the educational one is questionable. The race one is also questionable. I'll come back to that. So note, whenever you have I, it is changing across individual, but not across time. Whenever you have T, it is changing across time, but it's not changing across individuals. Okay. I have spoken about the unobserved heterogeneity, so take note of that. All right, so those are the terms I want you to take note of before we start. This is a specific panel data model. Who can tell me? So guys, what I want you to do is to tell me whether the variable is time invariant, time constant, individual invariant, individual variant, okay, and all of that. You tell me, looking at the variable. So when you look at life, it is changing across what? This one is easy, right? Life is changing across time and across individuals.
Yes, across time.
Does it make sense? Anyway, you don't know the variable. So this one is looking at the performance of insurance companies. The performance of insurance companies. And then you have life and non-life insurance. Life and non-life insurance. Okay. Then you have credit risk. You have leverage. You have the log of total assets. You have GDP. What do you see strangely about GDP? You can tell me, what do you see strange about GDP? GDP is changing across time.
Time.
Yeah, it's changing. What about inflation? So you can see that all the macroeconomic factors are changing. See, so if I come to your presentation and you are presenting, and I see that you are going to make inflation IT, that is a failure. Inflation is changing across time, but not across individuals. Unless you are doing a cross-country studies. Unless you are doing a cross-country, these are some of the things you got to take note of and note down. All right. Regulation, okay, it's changing across time. Some of them are deliberate. Watch out, the time dummies has been brought out. This is how you got to model it. The time dummy has been brought out. And then the individual specific factor and then the error time have been put together. Okay. We'll talk about why this is so. Okay, so note the element, note the time element, the individual element, and then all of the rest. At this stage, I want you to look at the wage band data that I gave you. Look at the wage band data. If you have your Excel, open it. If you don't have, follow me. Now let me try and open the wage band data here as well for you. So on your Excel screen, you will see the wage band data. The one we are going to use is the wage.dummy sheet. Wage.dummy sheet. I want to tell you a little bit of story about this. It has been done in the long form, okay, not in the other form, in the long form. All right. We are going to do a thesis, a journal paper together. And we are going to give it a title. Looking at the wage information that you have here, we are going to give it a title. Remember, but before we give it a title, let me give you a bit of a story about it. Now let's give it a title. This is a title. Let me show you. Because we are going to use that to understand a lot of things. The title is this: whose wages do unions raise? Whose wages do unions raise? A dynamic model of unionism and wage rate determination for young men. Watch it. It's for young men. Not young women, not young men and women, young men. This was a paper published by Vela and Webeck in 1998. They analyzed this data. They took the data from the National Longitudinal Survey. Watch some information about the data. The data was from 1980 to 1987. The people were 545 full-time young men. Who can tell me the sample period? How many years? Be careful. How many years? Is it 7 or 8? Oh, it is already on the screen. That's why. I mean, if you are smart, you see it on the screen. So this is a balanced panel data, 8 years, and we have 540. So how many observations are we talking about here? How many observations? Bernice.
545.
Okay, Bernice, that is not the number of observations. Who can tell me how many observations are we looking at here?
4,360.
That is the number of observations. So the number of observations are always more than the sample size. Look at that. The sample size is less than the number of observations. Take note of that thing, because sometimes it confuses people. All right. Now let's get a bit of information about the data. So the first point is this. These youth have just completed their school by 1980. So by 1980, most of them have graduated, and they are supposed to work from the year 1980 to 1987. They are very young kids. They are between the ages of 17 to 23, just like you may have in the University of Ghana here. They have entered the labor market fairly recently, so they have average of 3 years of experience. Okay. That is their level. So at the time of the sample, at the time of the year 1980, you know, they do a lot of internship. So by the time they finish school, they've done the internship. And that is why by the year 1980, they had at least an average of 3 years of experience. Now let's look at the data. Okay. The Excel data. The ones I have highlighted are the green ones. The green ones, which is also what you have, is what we are going to focus on. But before we talk about the green aspect, note that the ID deals with the individual index. The year, the age are all there. Now, what do we mean by the age here? You don't take it, you might not understand what the age means. What do we mean by the age? Okay. The age. You can see 0, 0, 0, 0, 0, 0. Okay. So that means that the person, the age in question within that time period is missing with the person. If you look at, for example, experience, the number of years of experience for that person, if the person entered in the year 1980, his experience will be 1. But if you look at some people, for example, look at the individual person 17. His experience when he's joined was 4 years experience. So by the time of the 8 years, he has 11 years of experience. So some people don't have experience, don't have, 4 years, but they have 1 year at least experience. Whether the person is married or not is shown. That's a dummy variable. So you see no, but some are yes, especially those with 4 years of experience. Ethnicity. The ethnicity, there are multiple of them. You have other being shown here, but you also have Black, Hispanic, okay, before you get the other. What you are seeing here is other, but there are more that are not like that. Okay. As you go further, you get it.
All right. Please, did you explain the ID that some were 13 and some were 17?
No, the ID is just the ID is just a number given to the person.
Okay, sir.
It's just a number, like your university ID. That's what is there for the ID. Disability, whether the person is disabled or not, that's a dummy variable. Okay, rural, region, the region, okay, it's also a dummy variable. Okay, what do we mean by the region? What do we mean by the region? Okay. And again, some of these terminologies, just some of them they work, some of them they don't work. So where the person is located, that region can be northeast, it can be northern central region, southern region, or other. Then the salary, the wage of that person, the wage, you can see that $3.3 and all of that. That is a numerical variable. The sector the person is working in, the occupation, and then the level of education. You can see the person has 14 years of education. The next person has 13 years of education. Then the log of the wage, that is a L wage. The experience has been squared. We are going to talk about this. And now look at the dummies. See, the year 1981 is the only one having what? 0. Anybody else in the column for 1981 is not the 1981. So it's given a column number 0. The 0 means that it is not the year 1981. That is how you create dummies. Okay, so when we talk about the time dummies, that's what we mean by the time dummies. All right. So fill your data, understand your data. We are going to have some research questions to answer, to be able to answer, analyze the work. Has a return to education changed over time? We're going to answer that. What is the effect of unions on wages? We're going to answer that research question. How does this change by worker characteristics? What are the key forms of worker heterogeneity generating the endogeneity of union status? We look at that. With what form of economic sorting method or behavior in terms of union and non-union employment are the data consistent with? So let's get some few things right. Number one, we are filling the data. We are filling the data. Some of the variables change over time. Do you see that? Look at your own data. Who can tell me? Oh, I think I have all mine. Some of the variables change over time. For example, if you look at experience, let's go to see experience. Look at experience. 1 year, 4 years, 9 years. Oh, sorry. Experience. I was looking at experience square. So look at experience. Every year, the experience of the person is increasing. Every year is increasing. So that shows that experience is changing over time. So what letter should we give to experience? Is it I or T? Is it I or T? Or is IT? Is it I or T or IT?
IT.
Oh. Is it I or T or IT?
Dog, IT.
You are saying the thing and you are laughing. Joseph, tell him.
Oh, no.
It is both IT. Yeah, it's both IT because
yes,
experience changes with time and also.
Ah, okay.
Yes, sir.
Yeah, you can see it from here. See, okay, this guy has an experience. It's changing over time. Okay, but this one is changing. But don't you think that experience will be changing deterministically? Because every year we are all changing our experience by 1 year anyway. So eventually our experience is the same. Think along that line. Okay. Let's go to the next variable. The next variable is marital status. Do you realize that it is changing? Marital status. You don't see it, but me, when you go deeper, you see that some of them start getting married. And look at this one. Look at this one. It was no. Look at number 45. And then the last one, it was what? It was yes.
Yes.
So you can see that marital status is changing. Look at even the next one after that. Okay. Person number 110. Look at that person's situation. It was no. Then it became yes. Come on, they are young people. They need to see life. And so they were changing their marital status. So marital status in this context is changing. But normally you would think that marital status is what? It's a dummy variable, eh? But it's changing. Keep that in mind. Okay, keep that in mind. And I'm doing this thing for a reason, because the kind of data you're going to use for your panel data analysis, you need to really understand what we are doing before you can even look at it. Now look at the union status. Union status is changing. Look at union status. Okay. Union. Okay. You can see that this guy didn't belong to a union, but subsequently joins a union and then leaves the union again. Okay. So union is changing for some, as you can see here. So union is changing, belonging to a union. Ideally, you would expect that belonging to a union would be a dummy, isn't it? But it's changing. Remember, these are young workers. Okay, so other variables don't change over time, and it's quite strange. Okay. For example, race. Look at race. Okay. Look at race. Where is that? Ethnicity. That ethnicity, it has to be fixed. Those ones are time constant variables. Time constant. Take note of that. Because when I give you an Excel sheet, I'm expecting you to be able to identify all of these things by yourself, using the points that we are discussing. Education is quite questionable because education is fixed. Because remember, these guys have left school and they have started work. And so they are not schooling over that time period they were working. So education is roughly constant over the 5 years. Okay. But so please know that education here is fixed. Even though normally we know education is not fixed, but in this context, education is fixed. But when you have a variable that is fixed, it is quite nice to look at or interact that variable with a time dummy. So it's nice to interact education with the year dummy to test, listen, to test if return to education was constant over time. If return to education was constant over time. Return to education is your wage. So you can check whether wage is constant or wage is not constant over time. Gender. If gender was here, I'm telling you, gender would have been part of those that are fixed. Okay. But these are only men. These are only men, males. So reasonably, gender. Okay, now the UI captures the unobserved factors. So all of those time constant variables that affect the independent variable. The dependent variable, that's it. All right. Now I want you to go and look at experience square. Look at experience. Now I want to tell you something very important, because all of these are my questions. If you look at the variables, some of the variables have been logged. Look at the log of wage. Why? Who can tell me why some of the variables have been logged? Why do we take the log of wage, but we don't take the log of education? Isaac. Isaac.
Doc, please, my understanding is that it eliminates the problem. Hello, Doc.
Yeah.
Hello, Doc.
Yes.
Hello.
I'm listening.
Doc, please, it eliminates skill problem. Doc, please, it eliminates the problem of skill and outliers.
Yo. What is the problem of outliers? Okay. Why? Why do you have to take the log of some of the variables? Thank you, Isaac. Who strengthened what he said? Why take the log?
I was actually thinking differently.
Who is talking?
I thought that it was.
Who is talking that I don't see the hand?
Oh, I see my
Please,
hand.
I need to see your hand, then I can follow you.
Now?
Yes, Adwa.
Thank you, sir. I was actually thinking that it had something to do with other factors like inflation, etc., that would impact the figure.
Okay, so explain what you mean by that.
Hey, Doc, so that means already is not true. It's okay. I won't make a suggestion again.
I didn't say that it was true. I said explain what you mean by that. I said that means already it's not true. Your mind is telling you already. And so I say explain, now you are concluding. If I said explain, then let me give you $10,000. Would you have said it already is not good? Inflation is because it's because you are afraid. You are correct. It's because you're afraid of explaining, or maybe you are taking it from somewhere, so you didn't want to commit yourself. There are some variables that are affected by inflation. Most variables like income are affected by inflation. Your age is a number, but it's not affected by inflation. You get a point? So you're not going to take the log of my age, but you take the log of an income, because income devalues all, increases in appreciation depending on the exchange rate. So such variables, they change. They are no longer in nominal terms. You've got to take their real terms. But how do you get a real values of some of those? What is a real wage? The nominal wage is the one that is in your bank account. What is a real wage? The real wage is your purchasing power, your power to use that nominal money to buy. Now, it's very difficult to get data on that. So one way you can deal with that nominal wage is, one, use a price deflator. You deflate all the variables and put them into a particular constant price. So let's say that all the variables in the year 2000, 2002, up to 2020, you measure all of them in 2020 terms. You normalize them. You use a price deflator. That's one way. The second way is to take the logarithm. Take the log of the nominal way or the nominal variable, converting it. Okay? When you take the log of it will convert it into percentage terms. So when you actually take the thing, we are not dealing with percentages. We are not dealing with real values. So you can say that an increase in something, a 1% change in this will lead to 50% change. So that it doesn't matter which year you are in, it is percentages we are dealing with. When you take the log, it helps you to now express the whole thing in percentage terms. And of course, it takes care of the inflation or the nominal element in it. So that is why we take the log of some of the variables. So you can see that we've taken the log of the wage to impose that constant percentage effect on the independent variable. Now look at another variable, is experience. Experience. We have squared experience. Why? Why? Yes, Boyson.
Please, in a situation where you have some of the independent variables being in percentage terms, and you have a log one, like you have a log variable, can you just go ahead with it like that? Or you have to turn it into percent, or you have to log the other ones in percentages as well?
So what you mean is that you have the variable already in percentage.
Yes.
You don't need to.
Thank you.
You don't need to. It's already sorted. So you don't need to.
Thank you.
So let's go to experience. Experience has been squared. Sometimes in your regression, you don't just take the log, but you also take the square, sometimes even the cube. Why do we square some of the variables? Why do we square them? Well, I want you to have it in mind. The word square gives into the principle of quadratic. Okay, let me give you a drawing, then you can appreciate it better. In a quadratic graph, okay, in a quadratic graph like this, okay, when the thing is going this way, it is rising. The relationship between X and Y are positively related, isn't it? They are positively related. Now, the moment you get to the top, okay, and you start sloping it down, the relationship between X and Y is becoming negatively related. But when I am looking at it, I don't look at the positive and the negative alone. No. I look at it as a whole. So what I'm trying to say is that the relationship between X and Y rises. Sometimes it gets to a point, reaches a maximum, and then boom, it begins to fall. What brings about the falling nature is because of diminishing marginal returns. So let's take in real life situation, things that can experience diminishing marginal returns. Experience. You take some footballers. Okay, now Ronaldo and Messi are experiencing diminishing leg returns. They were so powerful in those days of the 2000s and 4 and 5 and 6 and 7 and 8. Now they are slowing down. Okay? So experience increases, reaches a peak, begins to dip. And that makes experience having a quadratic distribution. And you got to capture that. So if you have a belief that a particular variable might exhibit that, capture that. Because if you don't capture that, sometimes you are punished. Maybe you want the variable to be significant, but it's not significant. Because the way you've carried it out as a linear variable, but it's a quadratic variable. That's why you got to take. But you see, because of that, that is not to say that because of that, you go and square everybody. It has to be justified by the literature. So there must be theoretical backing or literature backing. Others have confirmed it. If you want to do it, then you need a theoretical backing. For example, the Giffen paradox, the Giffen good, it says that the higher the price, the lower the quantity. But you need to gather data. So maybe you would have gathered some ostentatious variables, luxurious diamond rings. And you've seen that for such variables, the higher the price, the higher the demand. So the data is bringing the theory out. But you don't just go and say it. So the data is telling you that this should be theorized. And then you can now actually make that point. So it must be backed by data. That the non-linearity of such variable. Another variable is size. The size of a company is measured by the total asset of the company. So it is believed that when the company is getting bigger, is good. But at some point, when you become mega, that is not good, because you see that management can't even find who their employees are. The manager will sit in the left. His employee joins him in the left. He doesn't even know that that is his employee. Because the people have become so many, the company has become so big that you can't even monitor. There's a lack of monitoring. There's a lack of guidance. There's a lack of coaching and things like that. And so that becomes a kind of a disadvantage to oversizing. You got to capture that. So you take the log or the square of the size. So you don't include just size, but you include the square of size. But because size can also, the size of the company, which is measured by total assets, which is income, can be experiencing inflation. You need to take the log of that before you come and take the square of that. So the same variable, you take the log, take the square. Beautiful. You are modeling. You are modeling. You are modeling. That's why you are a doctor. You think being a doctor is easy. You got to be modeling. You don't learn how to model, don't even go and take that title on you, because once you call yourself that title, people are expecting a lot from you. They are demanding that from you. It is not a prestigious alone. It's cool mortum, what was the name? Q mortum datum. To whom much is given, much is expected. So don't just go and call it, I'm a doctor, I'll become a doctor. You will suffer. It comes with issues. Okay. So begin to learn how to do the modeling of some of these things. Okay. So we have looked at this log, we have looked at the square. Okay. Another thing, and let me just take you back today. I'm taking my time here for a reason. Okay. Another thing that you might encounter whenever you are doing this work is interaction and then mediation. There are some predictors, independent variables, that will be interacting with other variables. For example, you can multiply experience with education. Because you believe that when experience interact with education, they are best able to affect their wage. Oh yeah, you have a high education, you have high experience, put together, your wage must go. So you can interact such variables. Okay, because you believe that such variables on their own, they do not affect the dependent variable by much. So you got to include them by multiplying them to capture that additive, non-additive effect. But you have to be careful not to add anything by heart and multiplying everything by heart. If you don't take if you have 14 independent variables, by the time you finish, you have done 300 variables because you are multiplying everybody by heart. That multiplication must be justifiable by theoretical terms. So there must be a theory that says that when there is an interaction between this and this, okay, there is likely to be an impact. You've got to get a theoretical backing. You can also interact a variable with a binary dummy variable. Please note, for example, a dummy variable like, say, time. You can interact a variable with that. You can even interact two dummy variables. And of course, you can also interact a dummy variable and a continuous variable, or two continuous variables. You can do all kinds of interactions, but they must be justifiable. Okay. So take note of all of these factors that we have considered. Ladies and gentlemen, now let's look at the general panel data. I want you to look at this because you are going to do it yourself right now. This is the general panel data model. Pooled OLS is OLS, but there are several times. Did you realize that your model, I've given you your assignment, it is a cross-sectional assignment you are doing, but I've given you a panel data. Do you realize that? You have to estimate that model like a pooled OLS. Pooled OLS is good, but it ignores the unobserved heterogeneity across the groups or even the time. It considers every observation as independent of the other. So when you have a particular observation like bank, okay, you're dealing with Ghana Commercial Bank, and Ghana Commercial Bank is appearing 7 times. It will consider Ghana Commercial Bank 1 as independent from the Ghana Commercial Bank 2. It will consider them as separate entities. And that is one challenge with pooled OLS. It assumes that the effect of each independent variable is constant, which may not be true. So pooled OLS is fantastic. And you have to run pooled OLS first. But let's try and get something why we don't have to use pooled OLS. Why don't we use pooled OLS? And again, sometimes it will work because you have to do something called pullability test. If pullability test says that pooled OLS is good, it's good. But I'm just showing you when it is not good. And this is when. OLS estimators must be consistent. They must be best linear, unbiased estimators. That's one, but they must also be consistent. Okay, what does that mean? What it means is that the covariance between the error term and the independent variable must be 0. We have said this over and over. This is the principle of endogeneity if it is not 0. If the error term, okay, is not correlated with the independent variable, that is the covariance of the error term being 0. So when you have that thing, there's no issue. But when they are correlated, then you have the problem of endogeneity. And when that happens, the unobserved factors can affect the independent variables because they're correlated. They're correlated. So the unobserved factors can affect the independent variables. So if you use OLS, the OLS is going to be biased. Why? Because one of the assumptions of OLS is that they must not be correlated. But you are going to use OLS or pooled OLS, either way is the same, to do the thing that is going to give you biased estimate, biased coefficient, and inconsistent coefficient. And when your coefficients are inconsistent, you can't make sense from them. This is when using pooled OLS can be a problem. When there is that covariance between the error term and the independent variable being non-zero. So let's look at this situation practically. So I want you to go to your wage pan data. We are going to estimate the wage equation. We are going to include education and ethnicity, okay, as dummy variables. When we come to the fixed effect model, when I explain, okay, we are going to drop them out in the fixed effect model. So the time varying variables, the variables that are going to be changing over time are experience, experience square, union, and married. Please note, these are the time varying variables. Okay. We are going to include dummies for the dummies to be correcting for any possible time heterogeneity. Heterogeneity. Okay, time heterogeneity. So let's run the model. But first, let's estimate the model. This is estimation of the model. Watch the model estimation. This is a general model, and this is a specific model. This is an OLS, normal OLS. Guys, I have asked you in one of the questions to go and formulate the model. These are some of the ways to formulate the model. So the log of the wage, and you can see that I've taken the constant term out. It is dependent on the education. Education is both individual, it's changing across individual and across time, as you can see. Experience is changing across individuals and across time. Experience square is changing across individuals across time. Union is changing across individuals across time. Marriage changing across individuals, because we said that married and union, these children are actually changing their union and then they are getting married in the process. Ethnicity is not strange. Ethnicity is changing across individuals and across time. And why? Well, for this purpose, we just included it. Okay, just included it. But ideally, you know that ethnicity is not supposed to. Okay, you know ethnicity is not supposed to. So I just want you to note that. Now look at the time element. The time element is changing across time. The time dummy. So you can see that. And then of course the error term. The way you formulate it is important. Please note, I didn't bring the UI and then the lambda t. I didn't bring them because this is pooled OLS. All right, so now let's continue. Okay, so ladies and gentlemen, we are going to run the pooled OLS, okay? But I want to mention something before we go and start running it. Panel data models with pooled OLS, trust me, the standard errors are going to be wrong. But first, let's run the pooled OLS, okay? Let's run the pooled OLS before you appreciate that the standard errors are wrong. So let's go to the data set. And then let's load the data. Let me take you to the R. If your R is not working, you should turn it on right now. I'm going to create a new a new page for this work. So I've opened a new page. And I'm going to type and load the data. You should do the same thing. The name of the data is wage pan. Now I'm using the clipboard approach to load the data. You can do the same. So this is it, wage pan dot blah, blah, blah. I need to go to the Excel, go and highlight everything and bring it to that. You know this already. So I'm doing that. It's the whole data set. And I just did that. The data is loaded. It is showing down there in the console that the data is loaded. If you want to see the top part of the data, type head, and then into bracket the name of the data, wage pan. Just watch. It's just going to show you the top 6 of the data. See? So it is giving you just the top 6 observations. Okay, that shows that the data is beautifully and nicely loaded. Wonderful. Follow me. I'm going to ask each one of you to show me some of your results, and people are going to be smiling. Next, there is a package that we use for panel data. The package is known as PLM. You need to install that package, PLM package. You need to install it. So what I'm going to do is I'm going to go to packages. Let me just expose myself a little bit to the information. Okay, so under packages here, you choose install. If you have PLM, you can search for it in the search PLM. It will come, like mine has come. But I'm assuming that some of you don't have, so you click install and type PLM. If you have internet, you can install it. PLM. And once it comes, you just click install, and that's it. I have installed it already. So let me see those who are installing now. Let me see by hands, those who are installing now. If you are not installing, don't raise your hand. Okay, so for those of you who have raised your hand, Kofi, Odrob, Watson, Jefferson, when you are done installing, let me know. So I'm going to invoke that PLM. Okay, that's what I'm going to do. I'm going to invoke that PLM. So type library into bracket PLM. Library into bracket PLM. Yeah, Zelda.
Oh, Doc, sorry, I was just saying I'm installing it.
Okay, so library into bracket PLM and run it. That is if you have installed it, you run it. And when you run it, at the bottom of the console, you will see that it will tell you that PLM, you've done the running. Once you have done your PLM running, follow me, just follow me. Some will not follow me, some will be lost again, but I'm interested in those that will be following. There are a few things you can do with the data. Let's try to get a summary statistics of the data. So just type summary into brackets, wage pan. That will give you a beautiful analysis of the data. Every item in the data, you can get a feel. The minimum value, the first quartile, median, mean, third quartile, and maximum. You get it from that. Okay. Now, you can also generate more statistics. Okay. More statistics, like confidence interval, standard deviation, coefficient of variance, by using something called library pastex. I'm not going to do that, okay, but that's just for you to note that if you type library pastex and install, you can now use the command called start.describe. I mean, just this command. So first you need to install and invoke library pastex like this. I've just done that. And when you use start.describe wage pan, that will give you a description of the wage pan. You can see the beautiful work here. You can see clearly age. You can see something about age, experience. It's telling you the minimum value, the maximum value, the coefficient. So many beautiful statistics that you can have there. All right. Next. And by the way, you can also use describe command. Okay. You can use the describe command to get more descriptive stats by first invoking the psych command. I'm sure all of you have the psych command, so you can just do that. Library into bracket psych. Once you do library into bracket psych, you can type describe, okay, into bracket wage pan. And that will give you a descriptive statistics of all the variables in a beautiful way. Yeah, in so many beautiful ways. You have the mean, you have the standard deviation, you have the median, the trend, the minimum absolute deviation, and several other descriptive statistics. You have all of them there. I have done this multiple times with you, so I'm not going to explain them. Now you can see clearly from the results on the far left that the variables that are dummy variables have been starred. Dummy variables have been starred. That should tell you that they are dummies. Okay. The next thing, and again, we are doing all of these things before we even come to. When you are dealing with some groups, you can alter some of the groups. For example, let us assume that you want to describe the whole thing. One of the groups according to those that are married and those that are not married. Okay, you want to describe whether they are married or not married. You want to use the marital status to describe. So you can type describe by, okay, describe by, and then you type the name of the data, which in this is somebody's link is just playing music to my ears. Okay. So you do wage span, and then after you type your wage span, you can include all the necessary information, the group and all of that. Okay, you can have all of that. You can copy it and paste in there. Okay. But when it is your own data, and then you type the name of the group is wage span $married. So that means that you want him to give you a descriptive statistics for those that are married and those that are not married. Let's run it and then you see the results. This is the result. It's so beautiful. So watch the top there. Those that are not married are the yes. That is what you see down there in the console. And then those that are not married is a no. Look at the top. Where is it? There you go, the no. So you have the yes and the no, and it will give you descriptive stats for each one of them. It will give you the range, the skewness, the ketosis, the standard error, all of them. It will give them to you. So these are the first few things you need to do about your data before you go to the real deal. Okay. That's it. And then you can even identify some specific ones that you want to check. You can generate correlations. You can extract the dimensions of your data, generate correlations of your data. Okay. And then you can do what we're about to do here. Very important thing. It might not work because of the quantum of the data. It's called exploratory data analysis. You want to explore the data. You want to explore the data. Okay. And so one way you can use to explore the data, it's like you want to have a feel of the data, okay, because the data is quite large. So one way you can do that is using this command known as coplot. Coplot. So watch the command I'm using. You can use coplot, and then the dependent variable is the log of the wage, which is distributed with the year and the ID, the type that you want to actually indicate. And again, when you put the cursor on, the cursor gives you a bit of an idea of what you're. So you have the type. The type is the bars. So you want bars to show at the top. Okay, the bars at the top. You want them to show the ID, the distribution. Sorry, the position of the IDs. That is why you can see that I do ID giving the year giving the ID. And you want to do it from the left to the R, starting on the bottom row. That is a type. That is a type. When you actually have yours, you see it. I hope mine will show. I hope. Okay. So it says the margin is too much, but let's see. Let me just expand it and see. So what is happening right now is that, I don't know whether some of you can see, but it's giving you a picturesque, and this is quite detailed, this is loaded. So the thing is not able to show well. Now it's beginning to show properly. Okay. Give you a picturesque analysis of how the wage is distributed across the years. And you can see that the wage is heavily distributed across the years, and it is inside. If you look at all of them, majority of the information are not far away from the center. All of them are kind of nucleated within the center. Okay, so it appears there is some bit of normality, well-arranged log of variables that we haven't done if we had probably used a nominal wage. So that is one of the first things you can do. You can even do a scatter plot of the same thing. Okay, the scatter plot. Let's do a scatter plot of the wage and then see how it looks like. Okay. And again, you use the command known as scatter plot. You have all of this in the notes, just so you. Okay, so I've been told that the scatter plots cannot be done because, but, oh, there's no function. Let me see. Okay, so maybe you need a certain function, and I believe that it is the H miscellaneous. So you want to try the H miscellaneous. Let me run that and see first. Some of them have even been hidden. Anyway, so you can try this on your own and look at the scatter plot of some of the data. They are quite loaded, that's why. They are quite numerous. You can plot the means of the log of the wage. Remember, these are thousands. If you can remember, there were 4,000 of information. So probably that's why some of them will not show. Let's look at the means. This is to check whether there's some heterogeneity. I'm not getting most of my. Yeah. I think because I've squeezed the thing, that is why it was acting that way. Can plot the means. Let me plot the means according to. See, when you go and do this, you see that, and again, when you check the notes, you see that the heterogeneity across the IDs draws on the 95% confidence interval around the mean. And you can see that there is some level of heterogeneity. That's the key point. Okay. But my own isn't showing now. But when you do it, you see that. Let me show you the results. I think because having installed something is not shown. So you can see the heterogeneity across the workers. Okay. This is just exhibiting the heterogeneity across the workers. And you can see clearly there is a lot of heterogeneity that are exhibited across workers. Across the years, you can see again, there is heterogeneity. It appears that from 1980 to 87, okay, there is a rising, time. Time is heterogeneous. It's not constant. Okay, across the log of wage is heterogeneous across time. You can see that. All right, so let's go to, these are called preliminaries before you go to your real work. So this is the real work. We are going to run the pooled OLS. And to do that, we model the pooled OLS. So this is the model. We've gone through this modeling already. So we're going to run the pooled OLS using this command. And please note that we are using the library PLM. So if you have not installed the library PLM, you have to install it. What I'm going to do is I'm going to copy the whole thing. I gave the name W Pulse, just a name. And then I write PLM, the log of the wage, distributor with education experience, the same names that are in the Excel. And watch here carefully. This is the key. The index should be, column binded with an ID and a year. These are all in the Excel. And the model that we are going to use is pooling. This pooling is indicating that we are dealing with pooled OLS. And then the summary will give us the results. So this will run the one-way individual effect pooling model, and it will summarize the results. You can run the model without the year dummies. You can run the model with the year dummies. I have added the year dummies. By now, you should know what the year dummies mean. So I'm going to run this model. I'm taking it to the R, and then I run it, and then we can look at the results. So that's it. You make sure your spellings are all correct. You type these things as it is in the Excel, and then you run it. This is the result. Look in my console, and you see the result. Let me tell you something small about the results. One, you will see that this is a pooled OLS. This is a balanced panel. It is showing it clearly here. The sample size is 547, and the number of observations is 4,360. It has told you there. And then you have the coefficient. You know this in a multiple regression, you know it. And the stars are indicating the level of significance. The level of significance. Your job is that once you've done this estimation, you should be able to interpret the results. And I'm sure you can do all of this. When we come to the real life, I will interpret all of these results with you. Oh, okay. So Zaid is telling me that you have to install the function called gplot. Okay. So that's it. So go to packages, install gplot, and according to him, that will give you the graphs that I was looking for. Let me see. Let me see whether I will quickly get something. If your internet is good, you don't have a problem. If your internet is not good, don't even bother yourself. Because once you bother yourself, it will bother you. Okay, so the gplot, when it has been installed, let me see whether library. Is it? Where is his name? The guy who said I should install a gplot. How do you invoke it?
I just took it from the packages side. I didn't even call the library. The library is gplots with an S.
Okay. That's it. You're right. So guys, he's beautifully right. So you can see that the results are showing here. They are showing nicely there. That was the I think the co-plot that we did, and then we did the scatter plot. We did a scatter plot, and then the plot mean. It takes time. It takes time for some of them to come. Okay. Anyway, let's move on. Like I said, those are just exploratory. And this is the main thing, the pooled OLS, that's the result. Your job, our job we are going to do is to interpret these things. So my suggestion for you is that go and learn how to do the interpretation. We'll look at them when we have brought all the others together. But this is how you run your pooled OLS. This is exactly how you run your pooled OLS. Once you do this and you get the results, there are several questions I'm going to ask you. For example, which independent variable has the highest coefficient? Remember, some of them are in percentages. I'm going to ask you that. Which independent variable has the highest coefficient? I'll ask you to interpret it. I'll also ask you, what is the estimate of the return to education? I'll ask you to interpret it. I'll ask you to tell me about the marital status gap. I'll ask you, what do you think can make, what do you think of the estimate on the 1987 dummy variable? I'll ask you. So we're going to look at some of these things, how to interpret the scores. And then we'll look at the standard errors. Okay, and I can tell you that the standard errors have a problem here. We'll correct it. We'll correct the standard errors to see whether we'll get a better standard errors. And then we will use white heteroscedastic autocorrelated standard errors, the cluster heteroscedastic consistent standard errors which is robust to serial correlation and heteroscedasticity. We use that to solve the problem of the standard errors. So one can still use pooled OLS. It can still correct for any possible anomaly. So we'll look at that when we meet on the next time. Yes, Samuel, you have a question?
No, when I ran it came error in PD, said that ID does not exist. What does it imply?
Can you share your screen?
Interesting. I'm using my phone and then okay, I can in a minute.
You have installed the PLM, right?
Yes, I've installed it.
You have librated it.
Run the summary statistics as well. And then the other group statistics, I was able to run it. But when I was about to run the pooled OLS, it says error in P data frame, variable ID does not exist.
Variable ID doesn't exist means that maybe one of the variables, did you copy the entire data set from Excel?
Yes, I did.
Well, it's possible that you missed the ID.
Oh, okay.
It's possible that you made the ID. If I should look at it, I can quickly correct it.
Okay.
You are working on your machine, so it means that we can look at it.
Yes, Doc. I'm using.
No problem. So what you have to do is that recopy the entire data. Make sure your spellings are correct. R punishes you when you have wrong spelling. Okay, maybe there's a dot, there's a comma you have put somewhere. Okay. Sometimes when you are copying things from the PDF to the Excel, you can copy certain things that are not supposed to be copied. R changes them, so you have to go and check it.
Okay. Thank you very much, Doc.
All right. So, ladies and gentlemen, I want you to do it up to this level, and then when we come next time, we are going to look at the questions associated with it. And when we come next time, we're going to run the what do you call it? The first difference model. We are going to explain theoretically and run it here. Run the first difference model. We'll eliminate the problem within the first difference. We will now, I'll show you the model for the first difference, which is different from the other one, the pooled OLS. We'll run the first difference. We'll compare the first difference with the pooled OLS. We will now run the least squares dependent variable regression. We'll run the fixed effect model. We'll explain detail what it means. We'll run the random effect model. We'll explain detail what it means. We'll compare the two, the fixed effects and the random effect. We'll compare those two. And then we'll now go to problems with the panel data, how we can solve the problems within the panel data. So we've got a lot of things to do next time we meet.